Hi, Professor Barr. This is my answer to the take-home problem. Okay, so this is what we're given. There's two objects that collide, and it creates a perfect elastic collision. So here's the mass of the first object, the velocity, and the final velocity, and we're supposed to find the angle that it makes when it bounces off of the second ball, which we're given that mass, the velocity, initial velocity, and we're supposed to find the final velocity, but we are given the angle that it makes when it collides with object 1. So, since it's a perfectly elastic collision that was stated in the problem, you can apply the conservation of energy, which means that the initial kinetic energy equals the final kinetic energy. So you can rewrite kinetic energy into 1/2 mv squared. And so I wrote it out for mass 1, mass 2, and then mass 1, mass 2 final. And once you plug in all the equations given over here, you get this equation. And then you just simplify it down. And then I got that the final velocity of the second ball equaled approximately 5.099 meters per second. Okay, so now that we have the velocity, we have to find the theta angle of the first mass after the collision. So, since all collisions conserve momentum, we can use the conservation of momentum equation, which can be written as the change in the momentum of the first object plus the change in the momentum of the second object, all equals 0. So I wrote this out. 0 equals the mass of 1 times the change in velocity, which is just the final velocity minus initial, plus object 2, mass of object 2, times the change in velocity. So you plug all these values in. Now here you have the cosine theta, that's the theta we're looking for. And then right here, the initial velocities, we only use the x component. So that's why you only see the 5 and not the 7, because the 7 is the y component. Then over here, the same thing. We were given this angle, so that's that. And then this is the x component of the initial velocity. So what I did is I moved this portion over to the other side, so it's negative. I divided both sides by 2 kilograms, which is right here. So I divide both sides by 2 kilograms. And then I added the 5 meters to this side. And then I was just left with the square root of 50 times cosine theta. Divide by square root of 50. And then I got cosine theta equals negative 0.43959. And then in order to find the theta angle, you take the inverse cosine, which came out to be 116.1 degrees. And so, if you look over here, my two answers are 116.1 degrees for the theta angle of the first ball, and then the final velocity of the second ball is 5.099 meters per second.